Hello everyone, in this session we will complete the exercise 13.2 and we will see the next concept. Okay, let me read the question first. See, the question is probability of solving specific problem independently by A and B are 1 by 2 and 1 by 3 respectively. Okay, what is given? Probability of solving specific problem independently. Probability of A is given, it is equal to 1 by 2 and probability of B is given, it is equal to 1 by 3. So probability of A and B is given. Now if both try to solve the problem independently, find the probability that, first one, there are two questions. First question is the problem is solved. The problem is solved. And second question, two questions are there. Second one is given, it is exactly one of them solves the problem. Okay, so this is given. Now see here, first try to understand this question. A and B are solving problem independently, right? And probability of A solving the problem is 1 by 2 and probability of B is 1 by 3. So this is given, and one more, what you have to find? The probability of that the problem is solved. The problem is solved is nothing but it may be by A or maybe by B or maybe by both, right? That means the probability of a problem is solved either by A or either by B. So that means you have to find probability of A union B. Any one can solve the problem or both. So what will be the formula for the first one? Here I'll write. Here you need to find probability of A union B. Is it clear? So that means the question is the problem is solved. Probability of the problem is solved means either by A or by B or both can solve. That means probability of A union B we have to find for the first one. Now for the second one, exactly one of them solves the problem. Exactly one of them solves the problem means either A should solve the problem or B should solve the problem, right? There are two possibilities there. One possibility is A solves the problem and B will not solve the problem. So A solves, B will not solve the problem. Or B solves and A is not solve the problem. Is it clear? Probability of exactly one of them is solves the problem. That means if it is A solves the problem, probability of A and B will not solve the problem means, that is, B will not get the answer for that. That means P of B dash. Is it clear? This is the probability of B is nothing but probability of a problem solving by B. Here B is not solved the problem. That is P of A into P of B dash. Plus, this is the one condition. If it is B solves the problem, then probability of B, and it is given that exactly one of them will solve the problem, then A will not solve the problem, right? So probability of B into probability of A dash. Is it clear? I hope you understood this. Now first let us go by one. So first one, what I have to find? Probability of A union B is equal to formula P of A plus P of B minus P of A intersection B. The thing is, you need to understand the question properly. Okay. See, the problem is solved. The problem is solved means it is by A or B or both can solve the problem. So this is equal to probability of A is 1 by 2 and probability of B is 1 by 3 minus probability of A intersection B. Since they are independent, I mean this event, probability of a solving problem by A and B are independent, we can write P of A intersection B as P of A into P of B, right? Since they are independent. Now just substitute the values 1 by 2 plus 1 by 2 minus probability of A is 1 by 2 into 1 by 3 and simplify and write the answer. Okay, this is for the first one. Now second one. See here, as I told you, probability of, I'll write here. So probability of a solving problem by A, then B will not solve the problem, that is B dash, plus probability of solving the problem by B, then A will not solve the problem. So probability of A is equal to 1 by 2. What is the probability of B dash? Will be equal to 1 minus P of B, right? 1 minus P of B. Or or else you write first P of B dash is equal to 1 minus P of B. So this is equal to 1 minus 1 by 3. So 3 minus 1 will be 2 by 3. Right? So probability of B dash is, here no need to write, probability of B dash is equal to by 3 and probability of A dash is equal to 1 minus probability of A. Probability of A is 1 minus probability of A is 1 by 2. 1 minus 1 by 2 is equal to 1 by 2. Let us substitute this. So this is equal to probability of A is 1 by 2. Probability of B dash is 2 by 3. Right? 2 by 3 plus probability of B. What is probability of B? 1 by 3 into probability of A dash is 1 by 2. Now simplify this so that you will get the answer. Okay, complete this problem. In a hostel, 60% of the students read Hindi newspaper, 40% read English newspaper and 20% read both Hindi and English newspaper. Okay, it is given. So let us consider H as the student who read Hindi newspaper, okay, and E as the student who read English newspaper. Now what is given? In a hostel, 60% of the student read Hindi newspaper. So probability of Hindi newspaper, 60%. Probability of that will be 60 by 100, right? So probability of a the student who read Hindi newspaper, probability of a English newspaper is equal to 40% read English newspaper. So this will be now 40 by 100. Then next what is given? And 20% read both Hindi and English newspaper. So both means it will be intersection. P of Hindi intersection English is equal to 20 by 100. Now these are the things given. Okay. Now you can simplify this. Anyway, in that the question is, a student is select at random. First question is, find the probability. Okay. Find the probability that she reads neither Hindi nor English newspaper. So she is not reading Hindi newspaper as well as English newspaper. What do you have to find? Neither Hindi nor English. So English is also not there, Hindi is also not there. So that means you have to find H dash intersection E dash. Right? H dash intersection E dash. So this is can be written as H union E whole dash. Right? You have to find H dash intersection E dash. This can be written as H union E whole dash. Now probability of H union E whole dash can be written as, it's of the form P of A dash will be equal to 1 minus P of A. So what I can write? 1 minus P of H union E. Is it clear? So this is equal to 1 minus P of H union B will be E, P of H plus P of E minus P of H intersection E. Now everything is known, right? P of H is given, P of E is given and intersection is also given. So substitute here so that you will get the answer for the first one. Okay. Simplify this. This is the first one. Second question is, say this one. If she reads Hindi newspaper, find the probability that she reads English newspaper. Try to understand the question. It is given that if she reads Hindi newspaper, so she reads Hindi newspaper. That means one event is done, right? Now you are finding the probability that she reads English newspaper. Is it clear what you have to find? Probability of, you are finding that she reads English newspaper, probability of English newspaper, but already she is reading Hindi newspaper. That is done. So that means P of E by H done. Is it clear? You are finding the probability of that girl is reading English newspaper, but already she is reading Hindi newspaper. So that means this event is done. So you have to find probability of E by H. So this will be equal to now P of E intersection H divided by P of H. Anyway, the value of P of E intersection H is known and probability of H is also known, and just substitute so that you will get the answer. Okay, that is the second one. Third one. Yeah. If she reads English newspaper, find the probability that she reads Hindi newspaper. Similar to this, she reads English newspaper. You have to find the probability of Hindi newspaper. What you have to find? Probability of Hindi newspaper. Already that she is reading English newspaper. So this event is done. So probability of H by E. So this is also equal to probability of E or H intersection E or E intersection H divided by probability of E. Substitute this so that you will get the answer. Okay. But if you simplify this, okay, these values, then you substitute, complete this. Come to the next concept, that is Bayes theorem. So far we have solved the problem based on one event. That means either it may be throwing a die or tossing a coin or drawing a cards. Those problems we have solved. But suppose if it is there more than one event, let me consider there are two bags, bag 1 and bag 2. There are two bags are there, and in this bag there are four colors are there. Four colored balls are there. Red, white and black, because there are three. Okay, red, white and black. Here also same colored balls are there. Red, white and black. Let me consider here 5 red balls are there, 6 white balls, 1 black. Here red 2, white is 3 and black is 4. Okay. Now I want to draw a black balls. Okay. If I want to draw black balls, there are two possibilities. Either it may be from the bag 1 or maybe from the bag 2. Right? Two possibilities will be there. If I want to choose from the bag 1, there will be a different possibility. If it is from the bag 2, different possibilities will be there. Such problems are solved by using a Bayes theorem, and this is developed by a famous mathematician John Bayes. That's why it is named as a Bayes theorem, and problem based on this is important for 3 marks. Okay, simple problems are there, so that those are important for 3 marks. Let us see this one. First we will see what is a partition of a sample space. Suppose let me consider the events E1, E2 till En are the events associated with the sample space S. Okay, there are many events, n number of events. E1, E2 till En are associated with the sample space yes. Then one more thing, the intersection of any event, Ei intersection Ej is equal to empty. There is no common elements between E1 and E2 or E1 and E3. There is no common element. Ei intersection Ej is equal to empty, and the value of I is not equal to j. Okay, if it is I is equal to j, then it cannot be empty, right? So I is not equal to j, and the value of I and j varies from 1 to n. Okay, Ei intersection Ej is equal to empty, and probability of probability of each event is greater than 0. Okay, probability of each event is greater than 0. There will be some elements in that. Then you can write E1 union E2 union En will gives you a S, right? I hope you are getting this one. See here, E1, E2, En are the events associated with the sample space yes. Then intersection of any those events will be equal to empty, and if I find the union of all the events, it will gives you a sample space. This is called the partition of a sample space. Okay, E1 union E2 union till En is equal to sample space. Yes. For example, let me consider the events E and F. Okay, these are the events E and F, and universal set is a sample space. Now, sample space can be written as, this is the one example, okay, can be written as, this is the one, what we can write this as E intersection with F dash, right? E intersection with F dash will gives you this one, E intersection with F dash union, I'll take this one, E intersection F, E intersection F, then I'll take this term, this as we can write F intersection E dash, right? F intersection E dash union, outer side part we can consider as E dash intersection with F dash, right? So this will be now E dash intersection with F dash. E dash means all the elements outside this, F dash means all the elements outside this. So this all the parts will be common, right? So this, if you combine everything, that will give you a sample space. No need to worry about this one. Just the thing is, partition of a sample space means any events will be there, any number of events. Okay, if you find the union of those events, that will gives you a sample space. That is the one thing you have to remember. And the intersection of any two events will be equal to empty. Okay, see, theorem of a total probability. Okay, this is not the base theorem. After that we'll see the base theorem. See this one. Let E1, E2 till En be a partition of a sample space S and probability of EI is not equal to 0. Let A be any event. Okay, there is another event. Let A be any event associated with S. Okay, A is any event associated with the sample space S. Then the probability of A is given by probability of E1 into probability of A where E1 is already occurred plus probability of E2 into probability of A by E2 till probability of En into probability of A by En. This one can be written as summation of the value of J varies from 1 to n P of Ei into P of A by En. This is the theory. Let us prove this one. Okay. See, it is given that E1, actually proof is not important. It is given that E1, E2, En are the events, okay, associated with the sample space. And so that we can write S is equal to E1 union E2 union till En, right? So we can write the sample space S is equal to union of all the events. Will give you the sample space. Next, what we'll do is let A be a event, okay, event associated with the sample space yes. Let A be the event associated with the sample space yes. Now I can write here A is equal to A intersection yes. Can we write like this? A is the subset of yes. So A intersection yes will gives you a A1, right? A is the event associated with the sample space yes. So A can be written as A intersection with sample space. So now this is equal to A intersection of sample space yes will be E1, right? We have this E2 till En. Clear? Now this can be written as, right, by using a rule A intersection E1 union A intersection E2 union last term will be A intersection En. So this is equal to the event A. A intersection Ei and A intersection Ej are the subsets of Ei and Ej. Okay, here this it may be anything. A intersection Ei and A intersection Ej, this will be a subset of Ei and this will be a subset of Ej. Since Ei and Ej are disjoint, I mean intersection of those two, Ei intersection Ej is equal to empty. By this we can say that A intersection Ei and A intersection Ej are disjoint. Okay, those are disjoint. I mean there is no common element between them. Disjoint for all I and j. By using this one, we can find the probability. Probability of A is equal to probability of A intersection E1 union A intersection E2 union A intersection En. See here, this can be written as probability of A intersection E1 plus probability of A intersection E2 plus probability of last term will be A intersection En. Is clear? By using the multiplication theorem, we have probability of A intersection Ei is equal to probability of Ei where Ei is already occurred. So this will be probability of A by Ei. Is clear? As I told you, this is not important, but understand this. Probability of A intersection Ei is equal to probability of Ei into probability of A by A. This will substitute here, right here. See, so by this we can write probability of A is equal to probability of A intersection E1 can be written as probability of E1 into probability of A by E1 plus second term will be probability of E2 into probability of A by E2. Similarly, the last term will be probability of En into probability of A by En. So So this one can be written as summation the value of j varies from 1 to n probability of ei into probability of a by ei. So we put this, see, probability of ei into probability of a by ei. Remember this formula, a b e1 e2 en are the events associated with the sample space. A is any other event, then probability of A is given by summation j from 1 to n probability of ei into probability of A by ei. Now we'll see the Bayes theorem. Okay, this is the formula and we'll be using this formula to solve the problems, and proof is also there, simple. Within 2 steps we'll get this answer. Okay, what is given? Let E1, E2, En are non-empty events, okay, which is constituted of a partition of a sample space, that is E1, E2, En will gives you a sample space and pairwise distribution. Intersection of any two events will be equal to empty, and if you take those together it gives you a sample space, and it is given that A is any event of non-zero probability, then probability of any event ei with respect to A is already occurred. So clear? Probability of event, it may be E1, E2, E3, En, it may be anything where A is already occurred is given by probability of ei, probability of A by ei divided by summation the value of j varies from 1 to n probability of ej into probability of A by ej. Okay, you need to remember this formula, simple basic. Probability of ei by e. Start with probability of ei. Here probability of ei is occurred. So what you can write? Probability of A by ei. Similarly, j from 1 to n, probability of ej, same here, and ej is occurred. So we can write probability of A by ej. Okay, let us prove this one. Simple proof. Actually, proof is not important here also. Just you remember the formula. P of ei by A. By using this condition, right? Here by using a conditional probability, we can write probability of ei intersection with A whole divided by probability of A, right? By using a conditional probability form. Probability of ei intersection A divided by probability of A. By using a multiplication theorem, probability of ei intersection A can be written as probability of ei, right? By using a multiplication theorem, probability of ei into probability of A by ei, where ei is already up. So divided by probability of A. So this is equal to probability of ei into probability of A by ei. Now divide by using a theorem of total probability. Just now we have discussed probability of A can be written as summation the value of j varies from 1 to n P of ej, right, into P of ej is already occurred. So this is probability of A by ej. This is a simple, right? Probability of ei, probability of A by ei divided by summation j from 1 to n probability of ej into probability of A by ej. So you need to remember this formula. In the next session, we will solve problem based on this theorem.